So, we've got the general understanding of what a factorial is, how it works. So we got the general idea of how it works. Let's see some practice. Okay. So, as soon as my, here we go. All right. Something to keep in mind. Remember, the exclamation mark, the factorial symbol for mathematics is you take the number that you start with, multiply it by the number minus 1, and go on down. The only one that's different is the 0. Okay? 0 factorial is just 1. It's not negative 1. We don't go minus, and we don't go 0. 0 factorial is always 1. Right? So when you have that, it's always, your numbers are always going to end. So 5 factorial is going to be 5 times 4 times 3 times 2 times 1. That's n minus 1, n minus 2, n minus 3, n minus 4, and then 1. Okay? So we don't need to write that second one in there. We don't need to write the 0 factorial in there. Make sense? Okay? If we do it the other way, then it's like dividing by 0. It throws all the rules for our math off. We don't need to write that. Okay? So 5 factorial, 20, 60, 120. So 5 factorial is 120. Okay? And then we did 5 factorial divided by 3 factorial. Very much the same, so you should be able to tell me what that is. 20, we did that. Okay? Because remember, we don't have to go all the way down. I just have to go down far enough to cancel that guy out. But what happens when I have a factorial divided by the product of 2 other factorials? What happens there? We could, but these, we can treat them just like exponents. We forget the rules for exponents, expand it out, see what happens. Okay? 5 factorial, 5 times 4 times 3 times 2 times 1. 3 factorial, 3 times 2 times 1. 2 factorial is 2 times 1. Bunch of different ways you can do this. Okay? Bless you. See anything that we could do? Well, we know we could take out the 2 factorial, right? By following the same rules that we did with the 5 and the 3. Those are gone. But then what happens? Can I take out the full 3 factorial? No, I can't because I already took out the 2 and the 1. So the only piece of that 3 factorial I can take is that 1. Or I can say, oh, well, I can take out the full 3 factorial, but then I got the 2 factorial left. So it's 6 and 1/2 dozen the other. Okay? So up top, 20. On the bottom, 2. What's 20 divided by 2? 10. Okay? Anything different there? What happens there? What do we have to do?
So, are we allowed to do like 5 minus 2, 2, and then 2 factorial?
Is that what we do? This is mathematics, yes? Every time mathematics, all the time. Please excuse me, dear Aunt Sally. So first thing I do, parentheses. So yes, I take care of the 5 minus 3 first. Okay? So 5 minus 3 is 2. 2 factorial times 3 factorial. Well, that's the same thing as 3 factorial times 2 factorial. So we get the same answer. Okay? Now, the reason that we have to go through factorials is because if you see this on a paper one, right, if you see the binomial expansion on your paper one, if you look at your, if you did look at your formula book for this, you'll see that to find the binomial coefficient, it's in terms of factorials. Okay? So you need to know what factorials are and how they work. Paper one. Paper two, there's two different ways to do it. You can still use that formula by hand, or you can use your calculator. Okay? Now, something that I want you to look at. Well, we'll do this. Hold on that one. I had a brain thought, but I'm going to pause it. Okay? So, I don't think we need to go through too many of these. Are there any of those that would be something crazy? They're all pretty standard, all following the same thing. Okay? Factorials are quite simple. They just go through the same process every time. That's it. Okay? Don't make it any more difficult. It's just multiplying in sequential order. That's all. Okay? So, if that's the case, let's look at this. This is straight out of your book, by the way. So if you want to, if you have your book, you can follow along. If you have your digital book, okay. Page number, let me see, should be somewhere around 183. It's in chapter 7. It's chapter 7. Yep, 183.
Are we always going to be plotting binomial coefficients with the calculator?
No, you're not always going to be able to do the binomial coefficients with the calculator. That's why that formula is in your formula book. Okay, so if it's a paper one, we have to find the binomial coefficient by hand. Okay, two ways. You're either going to have to use the formula that's in the book, or you're going to have to use Pascal's triangle like we used the other day, because those numbers match up. And that's what this investigation is. So right now, the NCR, okay, the probability, the NCR, you guys know what that is on the calculator. Okay, if you go to math, go to probability, it should be NCR. There's going to be an NCR, and there's going to be an NPR. We don't want the NPR. It's NCR. So right now, so right here, we're at the NCR. Okay, by paper, we don't write the C. We write it as kind of a vectorish looking thing. All right. So if you make your N3 and then do three different things, choose your R to be 0, choose your R to be 1, choose your R to be 2, choose your R to be 3. So in other words, you're looking at 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. And yes, you have to do it in this order. On your calculator, I think everybody has the TI. You have to hit the number 3, then go to the math, the NCR, and then hit the 0. Okay? What's that? 1, 3, 3, 1. Where did you see that before? Pascal's triangle. So if we do 1, 3, 3, 1, and we look at it, remember Pascal's triangle. 1, 3, 3, 1. So the NCR is the way to get your binomial coefficients through your calculator. Okay? Or I can use Pascal's triangle, or I can use my formula that's in the book. of my formula sheet. Okay? Any of those three are going to give me the same thing. Pascal's triangle in your calculator are going to give you just sometimes a little bit faster with a little less calculations to do. Okay? I will be completely honest with you. On your paper one, a lot of people choose to use the the Pascal's triangle, not the formula. Okay? Some people do use the formula, but a majority of my students that I found use the Pascal's triangle because in the IB paper one, you're only going to be using up to maybe row 5, row 6. So it's easier for some just to write this out and have a visual than to try to put all the pieces back into the formula. I'm going to tell you now, it doesn't matter. You get the same value. Okay? The benefit to using this on a paper one is that you see all of the coefficients versus use the formula, it's only going to give you one at a time. Okay? So it depends on what the question is. If the question's only asking for one, you might see the benefit to use the formula. But if you're going to have to produce the whole expansion, this might be a little bit better. Okay? A little bit faster. Right? Now, the way that it works, if n was 3, remember the rows go, the top row is what? What's the top row? What do we call that? 0. So we got 0. The next one is 1, 2, 3. Well, what else did we say? What power expansion is this going to be? Is it a first power expansion, a second or a quadratic, or is it a cubic, a third power, or is it a quartic, a fourth power? It's a cubic. We know the number of terms is always going to be one higher than the power. So if n is going to be the power. Okay? N is always going to be the power. Well, what is the R going to be? Well, what did we say? Well, if I expanded, let's just take A plus B cubed. Expand that out. What do we get?
A squared plus
Not A squared.
A cubed plus
A cubed plus
B cubed
A squared B
squared.
plus B squared A, or AB squared. Ah, why 3? Where'd the 3 come from? 1, 3, 3, 1. 1, 3, 3, 1, B cubed. Now, I'm going to write this slightly different this time. 1, A cubed, B 0, plus 3A squared, B 1, plus 3A1, B squared, plus 1A 0, B cubed. Now, can you tell me which one the R is? It's the what? It's the power of the second term. Okay? This one, the n, is the power of the binomial. R is the power on the second term. Okay? So, if you're looking for a specific term, this is the R that I'm looking for. Okay? Because 0, 1, 2, 3. It's not the first term. And that's where a lot of people make the mistakes. They don't go by the first term. It's not the first term. It's the second term. Okay, the R is the power on the second term. Fair enough? Well, instead of this, if we did it to the fourth power, what would happen?
4C0.
Yes. Well, we'd have a 4, 0, 1, 2, 3, 4. Okay? But you have to include the 0. That gives you your 1 more than the power. Okay? In other words, it gives you row 0, and then we can get the next one. Are we good? Bless you. A little bit too much partying last night. Okay. This should look fairly familiar if you look in your formula book. This guy right here is the formula for the binomial coefficient that's in your formula book. Okay? N factorial over R factorial times N minus R factorial. This is a very long way to do the same thing this does. Okay? So when your calculator does the NCR, this is what it's doing. All right? So if it's paper 2, okay, like I said, if it's paper 2, and you're only looking for certain terms, or even if you're looking for the whole expansion, you have a tool, use it. Just make sure you use it correctly. It's like a hammer, claw hammer. You're not going to take the back, the claw side, and try to nail something in. All right? Use the right tool, use it the wrong way. So in other words, don't flip these around. Yes?
So if we're given like factorial and we're trying to use it to calculate it, will we have to, is there any way to do the whole thing in the, like would we do just like any other problem, like could we do like 3 factorial?
You can put this in your calculator. Okay? You can, you know, if you wanted to find this, fine. You know, let's do 5 choose 2. Okay? Well, if I do 5 choose 2, that's going to be 5 factorial over 2 factorial, 5 minus 2 factorial. I can put that in my calculator. Okay? So, again, it doesn't matter which tool I use. If I want to use the formula tool, use the formula tool. You want to use the probability tool, use the probability tool. You want to use your brain tool, use your brain tool. It's okay. But I can do any of those. And they all should give you the same answer if I use them all correctly. Okay? So let's verify it. Put that in your calculator and find it out. And we can take that. So if I do 5 factorial over 2 factorial times 3 factorial, well, that's 5 times 4 over 2 factorial, or just 2. That gives me 10. What do you get? You should get 10. Okay? If I do this in my calculator and not calculate anything, literally put it in just like it is. So I go and I say, okay, 5, go to my math probability, factorial, divided by, make sure you use the parentheses for everything. 2 math factorial times 3 factorial, and I should get 10. Okay? Well, what's my n? 5. What's my r? 2. 5 choose 2. Okay? So 5 NCR2 and we get 10. Okay, so it doesn't matter which method we use, we will get the same value. Just make sure you put the values in the right places. Okay? Now, it's got to get harder, right? We can't stay this simple. The hardest thing that it's going to do is when they start mixing in multipliers of your variables to a binomial. So where you have to expand the binomial and have a multiplier out in front of it. And then they're going to say, well, find the coefficient of the x squared term. And if you don't put in that multiplier, you're not going to find the right term. Okay, so be careful with what they're asking. All right?
So we have to distribute the multiplier.
Exactly. Don't forget to distribute the multiplier. So if, in other words, in the case of, let's see, x times x minus 5 to the 4th power, find the coefficient of the x cubed term. Well, if I do that, if I have x times x minus 5 to the 4th power, what do I have to do to find the x cubed term? Which expansion am I actually going to look for? Do I want to find the expansion of the x cubed term? No. Because if I find the expansion of the x cubed term and then multiply it by x, it's no longer x cubed. What's x cubed times x? X to the 4th, which is not what I've asked to find.
Should we distribute it first and then?
I can't. So I find my what term? X squared term, and then multiply it by 9. But if it's just asking for the coefficient, and there is no other coefficient in here, if I find the coefficient of my x squared, that's where it gets tricky. Okay? That's where it gets messy. Okay, so be careful. Okay? These, when they're cut and dry, very simple, easy. When they start to look like this guy, you're in that test mode, you got the anxiety going on, you know you only got, you got 90 marks and you got about 2 hours, so you're trying to work to that 1 mark per minute. Mistakes happen. Okay? But if you slow down and you think, just take that half of a second longer. Yes, okay, if I find the x cubed, I find the expansion, but I get an x out here, so I find the x squared, and that's the one I want. Okay? So be careful and look at what they're giving to you. Okay? All right. Now, this is more in tune with what we are looking for. Okay? So, what happens when I expand this out? Okay, we have a binomial theorem. Well, we know we've done this. If we have some binomial to some nth power, we know the process that it goes through. Okay, we did that the other day with our Pascal's triangle. The first term is the highest power, second term is 0. Then the first term decreases by 1 in power, second term increases by 1 each term. Okay, and we get our coefficients from here. Okay, this binomial theorem puts all that together. Okay, it does the NCRs for each of the coefficients of this expansion. Because if I'm just looking for the variables, I can tell you which term the variable is going to be in. Okay, if I give you the 7th term, so if we have 7p squared minus square root of 2 to the 8th power. Okay? And again, this is where the trickiness comes in. What is the coefficient? Okay, because they throw the root in there. Keep in mind what happens when I raise a radical to an even power. You're going to get rid of those radicals. The odd ones are going to have the radical, the even ones are not going to have the radical. So be careful with that. Okay? So when we look at something like this, then here's my A, here's my B, no multiplier out here, but I can find what is the 7th term. Well, the 7th term is going to have, P is going to be, it's going to be 7P squared to the 8, square root of 2 to the 0, 7P squared to the 7th, 6th, 5th, 4th, 3rd, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Which term are we looking for? 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. I think I said the 7th term. Well, that's going to be 7P squared squared, square root of 2 to the 6th. There's your 7th term. Now we have to do the NCR. So we do, what's my N? The 8. Choose which position? 1, 2, 3, 4, 5, 6. Remember, the power of the 2nd term. 8, choose 6. Okay. What is 8, choose 6?
It's 28.
One, 2, 3, 4, 5, 6, 7th term, 28. You did your NCR and got 28. If you follow the formula, okay, if you do your factorial formula, you can get 28. So we know that we have 28 times 7 squared P to the 4th, square root of 2 to the 6th power. What happens? 6 power, change that to 1/2. 6 divided by 2 is 3, so we get 2 cubed. Again, IB likes to throw those tricky ones in there. So, there it is. Can't see it? Okay. All right, so just be careful. This is not hard, but it is complicated. Okay, so don't, what's that?
I don't understand what this formula is.
Speak out the formula, because it's the same one, right?
Oh, so the first thing is A plus B, parentheses to the power of n,
Uh-huh,
equal
uh-huh,
to A to the n,
uh-huh.
plus, it's like parentheses thing, with n over 1. Yeah. Then it's A to the n minus 1, B, plus, and then they like continue the
Uh-huh. That's your binomial formula that we just had on. All that's saying is keep in mind, when you have this binomial and you're expanding, you know that the very first term is going to have your first term to the highest degree second term to the 0 degree. Okay? The next term is your binomial coefficient, NCR. Yes. Okay? Remember, your power, choose one, which is the second term, the second coefficient of the second term in your row of your Pascal's triangle, or your NCR. Okay? Times A, and again, the first term is going to decrease by 1, so it's not going to be n anymore, it's going to be m minus 1. Second term is going to increase by 1, so it's going to be 1. Get rid of the n's. So if we had, so if I said a plus b cubed, then this would be a cubed remember, we got 3 choose 0, 3 choose 1. So in terms of your formula, that looks like this. If we're going to expand a cubic, okay, this is the very first thing we looked at the investigation. N is 3, it's a cubic. Choose 0, that's my power of my first term. 3, choose 1, power of my, I said my first term. My first power of my second term. My second power of my second term. My third power of my second term, and my fourth power of my second term. And when we do that, 1, 3, 3, 1. For the coefficients. Okay? Questions? Good question about that, though. Because that's also a reason why I don't like going by the formula book first. Because that formula is confusing. You brought the right hat today. Okay, so obviously we need some practice. Okay? Oh. All right. Coefficient of the x squared, coefficient of x squared in the expansion of 2 plus x to the 5th. Let's see what it is. That doesn't look like NCRs. Experience says once you go to the mark, oh, you're confident in bed. You guys just brought up an excellent point.
I don't use.
No. Had one person said it was 10. The other person said it was 80. Okay? One said 10, one said 80. Well, there's a big difference, isn't it? They're both kind of right, but one is actually accurate. The other one would have only gotten 1 mark. Okay? X squared term. X squared, we know there's a second term. Second term is going to go 0, 1, 2, 3, 4, 5, 6, 7, whoops, 1, 2, 5. 1, 2, 5. Okay? So 0, 1, 2, 3, 4, 5. Which term do we want? We want the x squared. We want this guy. So if we're doing the NCR, what's my n? 5. Choose, what's my r? 2. 5 choose 2 gives me what? That one does give me 10. But I know on that gives me 10 as my coefficient multiplier. But I've got to find my full coefficient, which means I've got to take my first term, 2, and if I want the squared term there, what is the power of my 2? 3. They always have to add up. Those two always have to add up to be what? They always have to add up to be my n. Okay? So if that's 2, this one's got to be 3. Well, what's 2 cubed? 8. 10 times 8 times x squared, so the full coefficient is 80. That's the catch. Okay? Yes. Okay? So yes, in a way, these were both right, but the full coefficient is 80. Okay? How about the coefficient of the x and x plus 3 to the 5th? Crack. Why are you wearing a crack hat? I can keep this if it says crack. You know what? Now you're a crackhead. Find it? Stop. Hey!
It's 405.
405. You insane. 405? Are you sure about that? Okay, well, we got a 5th power. We've got a 5th power. Well, we can use our triangle here. So we get a fifth power. I go 0, 1, 2, 3, 4, 5. So I know I go 1, 5, 10, 10, 5, 1. Expansion in the, I'm looking for the x. Well, which term is that? 5, 4, 3, 2, 1. First power. So I know I got a coefficient multiplier of 5. 5 times my first term to the first. Second term has got to be to the what? Fourth, because 1 plus 4 gives me 5. What's 3 to the fourth? 81. So I got 5 times 81 times x. What's 5 times 81? 45. Yes. Perfect.
How would I use the NCR for this? Like, would I just say 5?
If you use the NCR, it's only going to give you one term instead of what you did to get the full polynomial. Okay. So if we want to use the NCR, we would get each individual. We would have to do NCR for each individual term. Okay. Now there is a way to get NCR without going through all of the terms. Can you think of a way to get the NCR for all of your terms? In other words, how can I make my calculator give me my Pascal's triangle? It's not in math. But it is right here. Where do we go? Where do we go to make our calculator tell us values? What did you say? Y equals. Well, if I want my calculator to tell me values, I could go to my y equals. So I go to my y equals. Well, I definitely don't want it to tell me the values of e to the x divided by 4, so I clear that guy out, clear that guy out. Well, if I'm in my y equals, how do I get it to tell me values? I gotta put in my function. Well, what function do I want to put in? My NCR. So I can get it. We said this was a fifth power function. So n is 5. I want to know all of my coefficients for a fifth power expansion. So 5 is my n. Go to math, probability, NCR, 5, choose x. Now what? Do I want to graph this thing? No, I don't want to graph it. What if I go where? Table. There are my multipliers. 1, 5, 10, 10, 5, 1. So if your coefficient is the 8th power, I change my 5 to an 8. 8, choose x. 1, 8, 28, 56, 70, 56, 28, 8, 1. I can get any line in my period that I want as long as I know the power of my binomial. So I don't have to do any calculations now, as long as it's paper 2.
How did you get it? Oh, you changed to 8.
I changed it to 8, yes. So as long as I know my n expansion, I put my n value in, I put my r value as x, and I go to my table. And my table produces that row of Pascal's triangle. Okay? Now, you don't have to do it this way. You could do it individually. But now that you can produce the entire row, why would you? Because now, when it asks for the 7th term, I can count down to my 7th value.
8.
So if I want my 7th term, and notice that when we have 0, it's 1. So that matches up with what we have. When the second power, when the power of my second term is 0, the coefficient multiplier is 1. Okay? So if I wanted to go first, second, third, fourth, fifth, sixth, 7th term, there's the coefficient of my 7th term. If I wanted the x, or the second, the coefficient for my second term to the 5th power, there's my coefficient for the second term to my 5th power. So now I can use my calculator, and I don't have to use my rule, I don't have to use the stuff, I don't have to use that formula at all, I don't have to get confused. I can pull out any row in Pascal's triangle.
So the y, what we say about the second term?
The y, remember, that thing is the power of my binomial. The x is the power of my second term of my binomial. Not my first term of my binomial, my second term. Okay? So, that being the case, and using our newfound technology tool, now we should be able to do one like this. Come on. Coefficient of x cubed y squared in the expansion of x minus 3y to the 5th.
I mean, we have to go to 3 choose 2.
Remember, NCR.
Yes. So that's 10.
What goes in his end? Choose X. If you use your table. Or, if I want to do this, do I look at the X or do I look at the Y? Which one's my second term? My Y. Okay, so I want to find the 5, choose 2. Okay? Or I can use my table, okay, and come down to where I know that it's going to be an x cubed. Or I could do my x cubed as well. Okay? So it depends on which one you're looking at. If you use the table in your calculator, if you get the full row in the table, I don't have to worry about the n choose r for which one am I looking at. I can go, because if I get this, what do we have? 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Well, if I'm looking at the x cubed, this is x to the what? 4th, 3rd. So I'm looking at a multiplier of 10. First term is x, and I know that's to the 3rd power. 3y, it's got to be to the 2nd power.
So, when we have something like that, could we just look at what that's asking for x and see which one?
Yes. But it depends on if you're going to use the MCR, or if you're going to use your formula, or if you're going to use the table. If you're going to use the MCR, you have to look at this guy, because that's your R. Okay? So now, 3 squared is 9, 9 times 10 is 90. Coefficient is 90, x cubed, y squared. Fair enough? All right. Okay. So I'll take it easy on you. That's where we will stop.